So nice, my freshman, sophomore class.
It's muggy.
Junior year was okay.
Tornado watch.
Wait, really?
Mm-hmm.
Yes!
It's like,
I know there's like this huge front
I wanna
coming.
get caught
it's
in the
almost
tornado.
80 degrees outside. I had to go home and put a t-shirt on.
Dude, we should like,
Can we have Matt outside while it's nice?
Can't
I
we?
know, right? I want to.
I don't know if a Lamborghini.
What are we gonna do? Sit in the parking
I know,
lot?
right?
Yeah.
I can sit in my car. I can sit in my JT album I have in my car.
Oh, do you have the new one,
I
2020
have the
Experience?
CD.
Hate you.
Every
You can get it
song.
free on the library website.
Really?
Amazing.
I've been trying to download it and I can't find it
It's
anywhere.
amazing.
You can only do 3 free songs a week.
Oh,
but
can you?
yeah,
Still.
it has a lot.
Oh yeah, I go on that
I
website.
need that, because that's good.
It's a great album.
I've only
I know,
got the
it's
one
really-
song.
Yeah.
You should listen to Mirror.
Are your voice
You should listen to Mirror, that's
I heard
amazing.
that yesterday.
It's amazing. His whole album's just like slow jams.
I love him. He's just amazing.
He would play real music nowadays.
Mm-hmm.
He does.
How'd it go?
She said when Allie, she doesn't have the number, but Allie is, and when Allie is back in physical therapy, which apparently is gonna be today, like here at the school, she'll be back.
Oh, she'll be here for Calvin.
She'll bring the number.
How do we have the electronic?
Yeah, it said
It's
there was
just-
a tornado watch.
just
or
to- just to
warning
watch.
Or something.
Just to watch right now,
Even though
so
it's like pretty outside.
Isn't it muggy?
it's supposed to, yeah, it is.
Isn't it muggy? I feel like we're in
It's
Florida.
70s and humid right now.
Oh, it's cold.
But it's
Right.
supposed to be tomorrow.
Warmest
It's only
day
supposed to be
so far.
30s and humid tomorrow.
I know, if I
Yeah.
wish it was a nice day so we could go outside.
Smack.
The ground's all wet. It
Fogger.
had to have rained or something, I didn't see it
Single
rain.
family, I didn't think, but.
This couch would be electric intelligence producing on the board.
The difference between a tornado watch and a tornado warning, just for reference, is a watch means that the,
Conditions could favor a tornado.
Right.
A warning means
means
that
there's circular motion in the
there's
clouds.
spawn clouds.
Right, and we need the
So.
I'll look up the
why do we
Doppler.
go?
innermost room with no windows, so
This is like a
studio.
bathroom.
So this would be the worst possible room to
Yeah,
be
yeah,
in.
this would be a bad room.
You know,
We'd have to run into the studio.
Yeah, studio would be
And sit
good,
in the middle of it, because that's on glass.
yeah,
There's a
studio.
window in the roof.
Yeah,
What
that's
are the
true.
garage door?
Oh my
Yeah, the garage
gosh.
door.
You guys check that out.
Yeah.
You see
I
it?
saw that this morning.
Ooh.
Like, it's in it's near South Bend right now.
I live in cornfields, so my house is probably gonna turn tornado amazing, that's awesome. It'd be kinda cool to, I should ride with you.
Mhm.
I can't make it to Tyra. There's a tornado.
That's a legitimate excuse, I think I'm gonna use that thing.
The tornado took my homework.
Yep. The tornado took my car, so I can't make it a time when I drive by.
Yeah,
the gas
there you
station.
go.
Oh, hey, welcome to your car. Oh, I got a new one, just the exact same.
Smell and everything, so I just needed like $2 and then one
It's
is
ridiculous, dude.
Cause your car is perfect, $3 then.
It is.
Is this what we had up yesterday? Do I have the equal and 2 signs right as well, consistent?
Yeah, wait. No, the one, the second one was. I thought the other one now.
No. There's an equal to 0 on the second one and equal to 2. Yeah.
Perfect, thanks. So, this is a piecewise function. It's defined in pieces. There is a piece from negative infinity to 0, not including 0, and of course not including negative infinity, because, well, infinity is an unattainably large value. right? So we can't include negative infinity. It seems, I say it with a joking tone, but it's, I mean, it would be a joke to include infinity. Because, yeah, unattainable. So we've got a portion from negative infinity to 0. We've got a portion, or a piece, I suppose, that would be more consistent with the name piecewise function. A piece from 0 to 2, and a piece from 2 to infinity. Now, the piece from negative infinity to 0 is just a constant function of 2. So that'll look like that. The entire way, the function has a value of 2, 2, 2, 2, 2, 2, 2, 2, 2. Pretty simple.
What is Allie?
From 0 to 2, we have the function x. Now, there are a couple ways to think about the function y equals x. One way is to think pointwise and think, well, if y has to equal x, you're going to get points, and they look like that. That's one way to think about it. Another way to think about it is like that. Slope of 1, y-intercept of 0. That would also give you those exact same points, if you think about it for a second. So, I don't care really how you think about the function y equals x, whether you break it down algebraically to slope and y-intercept, whether you think about it pointwise, you're going to get this. 0, 0 included, and then up at a slope of 1 until you get to 2, not including 2. So it'll be something like that. Again, we only include the piece from 0 to 2, including 0, not including 2. Of course, the line y equals x would go on forever to the left and forever to the right, of course. But with the piecewise definition, we're only considering a certain piece of it. The other piece is 3 minus x. I think in this particular case, the easiest way to think of this is to write in mx plus b form. We have a slope of -1 and a y-intercept of 3. So the y-intercept is 3, down 1 over 1, down 1 over 1. Okay, there's a point right there. Down 1 over 1, and we're going to head off in that direction. And we made a graph from the definition of the piecewise function. The reason why piecewise functions become so important in calculus is because this graph would be an example of something that is discontinuous. I only bring that up just so that your mind is primed to why we would study something like this. Like, what's the importance of studying graphs in pieces? The importance of studying graphs in pieces is because when you get to calculus and we talk about continuity, whether a graph is continuous or not, it's basically, can you draw the graph from left to right without picking up your pencil or not? In this case, you notice that you can't do that. You're going to be jumping all around as you go from piece to piece. And in calculus, discontinuous functions are notable counterexamples. So we often use them. Now here's a particular challenge. Write the equations for the following piecewise function. I am going to draw you a picture of this function. And we are going to use this picture to come up with the equations for the function. This one actually ends up being continuous. So I'll let you copy that picture there. First piece is a horizontal line from 1 unit long, I suppose. The next piece piece is an upward diagonal line for however long that length is. 2 square root 2 if you're curious. And then the other piece is a horizontal line at 1. So this is the exact opposite process that we did before. Before we were given the equation and we produced the graph. Here we're given the graph and we're going to produce the equations. So it's going to be kind of working in the opposite direction. Now here's the way to do it, if you ask me. What you do is just take each individual piece, come up with the equations for each, and then consider the regions under which those equations are existing. So first off, this piece here looks like a horizontal line down at -1. So this guy has a function value the whole time of -1, -1, -1, -1, -1, -1, all the way across. So the first piece is a function value constant of -1. And then we have to say, okay, what are the boundaries for that condition? Well, we are -1 from 0 to 1. We look at the piece, if I may here, I'll draw in those boundaries to say that that's the piece from 0 to 1. You will get comfortable, I think, through going through a couple examples of writing that notation to say x is between 0 and 1. If you use less than signs in between your less than or equal to signs, that's the easiest way to write, like our number x is between 0 and 1. Now the next piece is between 1 and 3, right? We're going to have to come up with the equation for that. Now that is not a constant function, that is a line with a particular slope. What is the slope of that line? The slope of the line is up 1 over 1, rise over run, 1, agreed? The y-intercept of the line, you're going to have to backtrack to find the y-intercept. But if you do, you can see what the y-intercept is. The y-intercept is -2, pretty good, yeah? Because it would fall back to there, basically, it would go through -2. So the b here is -2. So if we were to write this out, it would be y equals 1x minus 2. But really, the 1 times x is just x. So we're going to write this as x minus 2 to be fully simplified in our answer. And this is on what region? The region between 1 and 3. So this is where our x is between 1 and 3. Tornado watch. I've got the thing on buzzer just in case it goes to a warning. We'll be on board with that. Then we'll go to the computer. The way that they do it now with their advanced radar technology is, well, better yet, don't even think of, they can show it really accurately. Here's Fort Wayne on a map, I-69, I-469, right? They'll be able to, on their weather maps, go like this, with like what looks like a megaphone of like the region where the storm is going to. So if it would go to a warning, what we would do is immediately go to the computer, check the computer, see if we're in the zone or not, and then determine whether or not we have to, like, take bomb shelter, like, locations or not, because, I mean, for lack of a better, well, shoot, the tornado sirens that you hear were originally bomb shelter sirens during the Cold War. In the case that, you know, Russia had a nuke coming our way. Yeah, and it was actually a civilian that wrote to the senators and said, why don't we use bomb shelters or the bomb shelter warning for tornado warnings? Wouldn't that be a great idea? We could save lives. And the senator's like, ooh, great idea. Like, if you got the stuff sitting there already and it's basically doing nothing because, well, the chance of us being bombed is probably pretty darn low, why not use them for something that has a higher probability that is still equally terrifying? The last piece up here, constant function at what? 1. the value of that function is 1, 1, 1, 1, 1, 1, 1, 1, all the way across. And that guy is everywhere right of 3. So there would be two ways to write this. We could either say when x is greater than or equal to 3, or if you wanted to, you could write it as x is between 3 and infinity. Just make sure if you do include infinity, you don't, if you do choose to write infinity, you don't choose to include infinity in your inequality. Yeah, that was a self-contradictory statement. If you do choose to write the infinity, make sure you don't include infinity with your symbol. Good?
Great.
Great, okay, that's what I was looking at. So, that's it. Yes, let me address, again, I may have gone through this yesterday, but I want to be clear about what's going to be on the quiz. So the quiz involves hyperbola. You should be able to graph hyperbolas. You should be able to state equations of asymptotes of hyperbolas. You should be able to do both kinds of hyperbolas as well. The way that I think of it, I am making a reminder to you. I always think when I subtract the y's, I do not have y-axis intersection, so these hyperbolas are the ones A units to the right, A units to the left, B units up, B units down. I think when I subtract the y-axis, I don't intersect the y-axis, I do include the x-axis, and that's what I'll be striking whenever I draw the two parabolas on either side. You should be able to do hyperbola, you also should be able to do ellipse. Ellipse is a very similar equation, but with a plus sign in between. And the way to graph an ellipse is you go A units to the right, A units to the left, B units up, B units down, and connect the dots to make an oval, basically. Two other things that we've seen a decent amount of is law of sines and law of cosines. Even as I write those law of sines and law of cosines, the order I'm writing those in is not only the order that we learn them, but also the order that I think you should try to apply them in any problem. Because if you can use law of sines, then avoid using law of cosines, it's going to be easier. If you try law of sines and it doesn't work, you'll always need it later, so it's nice to know it's there, but you'll have to dip into law of cosines for one step. But with both of these ideas, you can, with any triangle, given 3 pieces of information, find the other 3 pieces of information. When I say 3 pieces and 3 pieces, I'm referring to the 3 angle measures and the 3 side measures. I can give you any triangle with 3 pieces of information, you can find the other 3, always. That would be especially useful if you were a civil engineer trying to survey an area. It would be nice to know that you only need to get half the information. You could get the other half, just pen and paper. You've probably seen those surveyors before with a little like a tripod, and they'll have a little camera that's like talking to another camera, communicating location, because they're going to put a building on a piece of land and they want to know the lay of the land. Well, they would use law of sines and law of cosines rigorously, because rather than having to move these big cameras to all these different locations, which takes a lot of time, they can just do half the work with the cameras and half the work on paper. It's easier, right? Why do all the work in real life if you can do half the work on paper? I mean, call that lazy if you want, but that's, in my opinion, just smart. Saves time. And time is money, right? I'm sure you guys know that, right? Okay, good. What else do we got? Oh yeah, there we go. We dealt with polynomial equations, those were the even degree or odd degree, positively coefficient, negatively coefficient. The odd degrees are like the NFL referees that say like, it's good. Or the negative would be, it's not good. And the, excuse me, the odd degree polynomials are like your lines, positive sloping or negative sloping. And remember, it's like a line just by its end nature. The other thing that we did was piecewise functions, which we have on the board. So functions defined by pieces of the x-axis. And then the last thing that we had was exponential equations, just to bring back to memory. You could have 3 to the 2x plus 1 power equals 4 to the 3x minus 2 power. And you could find what x was. The number that will multiply 3 a certain number of times, multiply 4 a certain number of times to be equal. Remember how you solve that is by taking ln or log of both sides. That'll bring the power down, and then give you a log 3 or a log 4 or an ln 3 or an ln 4 that you can easily use a calculator to solve. So that's the quiz info. 1, 2, 3, 4, 5, 6, 7. Basically 7 ideas for the quiz tomorrow. So in light of that, any questions from the homework that I gave you last night? Yes? Oh, I need to make a comment. This is more for the back of your mind at this point, because the front of your mind should be focusing on the quiz, but just to, have somewhere in the back of your mind. For the final exam, that will be Wednesday, Thursday, Friday, it'll basically cover what we've covered all semester long, although if there's something that we only saw one lesson of and didn't see again, that'll be something that would get dropped off, but if it was something that we visited even twice, it will be included. And the stuff that we visited twice is stuff that we would have seen basically all semester long. You'll be surprised how familiar it will be once we start studying. But since it's a lot of information, I think this is fair. For the final exam, you'll be allowed a 1 8.5 by 11 sheet of paper with notes. So you'll be able to construct for yourself a 1-page reference sheet to assist you. I'm trying to be fair here for a couple reasons. Well, I'm just thinking about myself, and I'm about to be a student again, and thinking realistically about this. When I do when I ultimately get to the point where I'm finishing my PhD, I'm going to be spending 2 years on one problem. Let me say that again. I'm going to be spending 2 years on one problem. Now, how do you think they do that? Do you think they're like, you're going to be locked in a room for 2 years, it's you and a paper, go? No, it's not a test like that. In fact, what they encourage you to do is to read as much as possible, to become as knowledgeable as possible about your problem, so that when you come up with your solution, this is not going to be a solution like, the answer is 3, or something like that. What you're basically going to be doing is developing ideas as far as you can develop them in 2 years. So the more that you know, the more you're able to comment. The more that you're able to comment, the more exciting your research paper would be received. So, thinking about that, ultimately the end result of education is read as much as you can, learn as much as you can, and you're not expected to memorize it all. You're just expected to become an expert in it to the degree where, if you have to, you can go in the book, open it up, figure out the answer and move on from there. So having a paper with notes is, like, if I, as a PhD student in a few years, will be doing my research project, and I'll have a shelf full of books at home that I can go to when necessary to reference, then I think it's reasonable for you guys to have a sheet of paper to reference as you go through your test. Similar thought process there in terms of the motivation for me doing this. Mhm.
Do you get to pick your problem, or do they assign you what the next to solve?
The specific problem is normally assigned to you by somebody, but what it is that you want to study is normally determined by you. So you pick like a general area, you'll start a dialogue with the professor, and then from that dialogue, he'll probably be like, "It sounds like this is a good problem."
Where's our external hard drive? Let me give it to your sister. Because it's a terabyte, right?
Quarter terabyte, 250
250
gigs.
gigs.
It's in the,
That's enough.
okay.
Where's it at?
It's in the hall closet by the bathroom.
And it's just like a normal little one that looks like a book.
Yeah, it's
It's
a,
the size of a book.
Yeah, it's about, yeah. Maybe
Okay.
just, it's like the size of a panoramic picture, about that thick,
So I
yeah.
was telling your sister, instead of, she's taking everything and putting it on Google Docs,
Oh my
so
God.
she can share.
Yeah.
But the external, I mean, she can just take that and plug it into any system and drag anything she needs right off of it.
Mhm.
So I'm just gonna give it to her.
It's probably, yeah, it's probably gonna be a lot faster than that Google thing.
But you know, it is only a quarter of a terabyte.
Yes,
Okay.
I'm certain of that.
All right. Thanks, babe.
No problem, thank you, gosh.
That's so high.
Okay, questions from the homework? Which section are we in? 115, number 24. This problem this feels like an SAT question. I think there's just enough information here to make it accessible, but also just enough information here that it's kind of a challenge. Seems like just the right amount of difficulty. Find angle A, that's up here. Find angle A, then compute the area. Of the triangle.
Oh, I definitely forgot the area formula. Oh, bad.
So two parts, we'll work one at a time. First, finding angle A. Notice that these two sides are equal. So the angles opposite those sides are equal as well. That is a famous idea and a useful one to have in your head. And the one way to think about that is, the wider the angle opening, the bigger the side. So equal angles would have equal sides. That's what I think of in my mind. I feel like that's a condensed thought, because it encompasses multiple ideas at once. So if both of those are 72, they add to 144, and thus what's left is 36 degrees. Good at that? So, angle A, 36 degrees. Now, let's compute the area. Well, we know how to do area, generally speaking, right? For a triangle, it's base times height divided by 2. So if we know the base and we know the height, we're good. We don't know either at this point. So we're gonna have to work backwards to find it. Now, my initial reaction here is, let's drop in a perpendicular, and let's go from there. So if we drop in the perpendicular, we've got a 72-degree angle, and basically, let me draw half of the triangle here. We've got a hypotenuse of 10, we've got an angle of 72, and we want to know the x and the y, for lack of a better letter. So we can say the cosine of 72 degrees is x over 10. That can be solved out for x. And we can say the sine of 72 degrees
is y over 10. That can be solved out with